Okay, hi everybody. I'm going to go ahead and look at section 9.3 real quick. These are pretty easy problems. And so we'll just kind of pop around and see what we can do here. All right, so I'm going to jump in and we'll go ahead and do the first question. Okay, so this one is about tuna. And okay, so let's just read through it. It says the following data are assessments of tuna quality. We compare some measure of lightness, how light the tuna is, to the averages of consumer panel test scores in 9 lots of canned tuna. And I guess the idea is that people think that darker tuna is not as good quality, so that's all this is. It's just a matter of how light the tuna is. Okay, and you can see a 4% level of significance here. We're testing the claim that the population of XY pairs exhibits linear correlation. Okay, so that's our test for correlation. I'm going to go ahead and bring my calculator in, so I can pull this off here. Like that. And so I've got all these values and I got to put them in. So I'll just take a minute to do this.
Okay, so I hope those are all correct. And then the next column, you have 3.5, 2.9, and so on. Okay, so that's all 9. It's 9 plots of Cantu. Got it. So I'm going to just go through and make sure these are right. I don't want to end up in trouble. Okay, so real quick.
Oh, that should be a 58.2. Right there. Okay. Second data, 2 variables. Okay, this is all good. And now the R value, if you scroll up from the bottom, it's a little quicker to get there. Okay, so there's R 0.707, which is a little different from what I had before. So I'll delete that. Put in 707. Yeah. And then we'll check to see if it's right. Oh, good. 0.707 is the right value. And then I'll go ahead, and we've got that. And again, our N is 9 on this. So I'm going to go ahead and bring up my worksheet. Okay, so just in case you're wondering, I fried my laptop this morning. It actually caught on fire. The story is long, and I'm not proud of it. But anyway, so I can go ahead and start writing. So as we said, my R value is 0.707. And our N is 9. That's 9 data points. So now we're going to just describe how strong the relationship is between X and Y. And so again, this is toward the end of the 9.1 notes, but we said that whenever R is between 0.8 and 0.5, we call this a moderate relationship. Not real strong, but not weak either. So I'll go ahead and pick that it's moderate. That's the first choice up here. Okay, and that should be okay. Okay, and there's a scatter plot. The points do look like they're kind of aligned. Not great, but roughly a line going uphill. Okay, so that's fine. Let me check my part answer, make sure everything's good. Yeah, everything's good. So now we're going to compute our R square value. Okay, R squared is, we're going to do 0.707 squared. Okay, so I'll do that on the calculator, 0.707 squared. Okay, so it's 0.4998, which is just going to be 0.500. Okay, which is 50 0.0%. R square tells you what proportion of the variation in y can be explained by your explanatory variables. So in this case, it says what percent of total variation in total variation in tuna scores can be explained by tuna lightness using our line of best fit. And that's R squared, so it's 50%. Okay, and I'm just putting in a 50%, and we're good. Okay. Now, for our null hypothesis, we're testing the claim that linear correlation exists. So the null hypothesis should be rho equals 0. Rho is the population correlation coefficient. Okay, and so I'll just put that in. Rho is not a letter that you'll normally see on a typewriter, and that's going to be a little bit tricky here. See if I can get this to work. Okay, go away, keyboard. There we go. So there's a rho on the little template that pops up, and you want to press that button for rho. And the null hypothesis should be rho equals 0. Okay, and let's check that. And the alternative is just, these are always a two-tailed test, so rho not equals 0 is your alternative hypothesis here. Okay, so I'll put that down in the notes on the side. H1 rho is not 0. Rho is the Greek R, so R is the sample correlation coefficient. Rho is the population correlation coefficient. If rho is 0, then there's no correlation between your variables in the population. Okay, so then we have to compute our test statistic for this. So it's a t-test. Okay, and you can see the formula there, R over square root of 1 minus R squared divided by n minus 2. Okay, so the R is 0.707. Okay, and then it's over square root of 1 minus 0.707 squared over n minus 2. That would be n, I think up here it says 9, so that'll be over 9 minus 2, so 7, like that. Okay, and there's that. I don't know, maybe I should try and put my maybe I should put my calculator up there and see what happens. I'm having trouble. Okay, I'm gonna try it now this way. Put it right here, actually. Oh, it's too big. That's okay. No, maybe it's not. Maybe if I just do this. Yeah, it's pretty good. All right, let me just clear all that. All right, so where's the calculation? Right here. So fraction 0.707 over square root fraction 1 minus 0.707 squared over 9 minus 2. Oh, of course, that's 7. I could just type 7, but here I am typing 9 minus 2. Oh, God, what did I do? 1 minus, it should be 0.707 in that numerator. Oh, God. Come on. I'm going to hover over the 7 and then do second insert here to insert a decimal and enter. So 2.64495, and I'll round that to whatever they asked me to round it to. Like that, maybe. Okay, so put on our t-statistic here. 2.64495. It wants 3 places, so 2.645 I think I'll have to go. 2.645. Good. I think I'll do a check. Makes me feel better. Okay, so yep, 2.645 is correct. Now we need to do our critical values. These are two-tailed tests. So the degrees of freedom need to be n minus 2. So let's go ahead and put that note. And the alpha value is up here somewhere, 0.04. Okay, so alpha is 0.04. The degrees of freedom are n minus 2. Okay. And so we have to do table A2. So for degrees of freedom, again, we're going to go down to, n minus 2. N is 9, so n minus 2 is 7. Okay, so we go down to 7 degrees of freedom. And again, our alpha is 0.04, and remember to do 2 tails. Okay. And so I'm going to see if I can figure out a clever way to bring that table up here. So I think, what happens if I do this? Okay, so my alpha is 0.04, 2 tails, and I think we said 7 degrees of freedom here. Like that. So the critical value should be 2.517. That's plus or minus. Okay, so see what happens if I squeeze this. There you go. 2.517. I'll put the negative 0.517, and again it's 2 tails, so I have to put in a positive 2.517 there. Okay, and so that's all good. I think I'll check it though. And it's all good. Okay, so the only thing that's left is our p-value. Okay, so this is a little tricky, but I think we can pull this off. So I'm going to need table A3 for the p-value. That's here. And we have to look up our test statistic. So if you remember, the test statistic was 2.645. Okay, so 2.6 is what I'll look up here. And the degrees of freedom, remember, is 7. Like this. So 0.9823. Okay, so let me put in 2. I'm putting in my values here. 2.517 was for the critical values. Okay, and then table A3 was for the p-value. So the degrees of freedom, again, 7. The test statistic going this way, we put in a 2.6. Okay, 0.9823. I could do better. Okay, so I'll put down my this is my test statistic, 2.645. That's my t test statistic. Okay, area to the left is 0.9823. So the area to the right is 1 minus 0.9823. So we'll compute that. 1 minus 0.9823 on a real calculator is 0.0177. Okay, the p-value, you're going to have to double this because it's a 2-tailed test. So 2 times 0.0177. So on my calculator, I'm just going to say times 2. Okay, so it's 0.0354. Okay, a little bit of work to get that. Let's make sure it's right. So come on, here we go. Okay, so 0.0354, did I say? Yes. Like that. Okay, and again, I feel better if I just check this. So check it. And let's see. Perfect. All right, so the p-value is 0.0354. We're just focusing on the O3. 0.03 is definitely less than, I think our alpha was 0.04. Okay, I'm gonna double check that. Yeah, 0.04. This is our alpha. Less here means reject the null hypothesis, which said there was no correlation, and support H1, which had said that rho is not 0, which means there's not no correlation, so that means correlation exists. Okay, and so over here on the problem, I'm going with correlation. You know, we rejected the null, support the alternative, and the data support the claim that correlation, linear correlation exists. So it checks just like that, and I think that's the last question. So we got 11 out of 11, and so we are good to go on that. All right, best of luck to you.